In question number 21, it says that a closed container completely filled with water is accelerating on a horizontal track with an acceleration a is equal to z. If PA, PB, PC and PD are pressures at A, B, C and D as shown in figure, then. So we have to calculate the relation between the pressure A at A, B, C and D, right? So let's say the pressure at A is something P naught. We don't know the pressure at A, so let's assume it's something P. So we know that if the container is accelerated along horizontal, so when we move a distance 2L along the horizontal, then the pressure changes by rho into A into L. But here the acceleration is g and the distance is 2L. So we can write the pressure of D minus pressure of A will be equal to rho g into 2L. So from here we can say that the pressure at D will be equal to the pressure at A plus 2 rho gl. And since when we move along the vertical, the pressure changes with height, so we can write the pressure of B minus pressure of A will be equal to rho g h, but here height is L. So we can write pressure at B minus pressure at A will be equal to rho gl. So from here we can say that the pressure at B will be equal to pressure at A plus rho gl. So this is the pressure at B. Again, since B and C are at the same horizontal level, but the container is accelerated towards horizontal, so we can say that the pressure at C minus pressure at B will be equal to again rho into A into the distance. That means rho into A is how much? G, and distance is again 2L, right? This is the 2L distance. So we can say that it will be equal to 2L. So we can say that pressure at C minus pressure at B will be equal to 2 rho gl. So pressure at C will be how much? Pressure at B plus 2 rho gl. But we have already calculated the pressure at B, that is PA plus rho gl. So if I put the value here, so you will get pressure at A plus 3 rho gl. So if I compare this and this, right? So if I compare these three, we can see that the pressure at C will be the maximum. Pressure at B will be more than PA, right? But less than pressure at D. So by comparing this, we can say that the pressure at A will be the lowest, and pressure at B will be more than pressure at A, and pressure at D will be more than pressure at B, and pressure at C will be the maximum. So we can say that our option number 2 will be the correct choice. Now let's move to the question number 22. In question number 22, it says that a bent tube is lowered into a water stream as shown in the figure. The velocity of the stream relative to the tube is equal to V is equal to 5 meter per second. That means the liquid is entering from this side with speed 5 meter per second. The closed upper end of the tube has a small orifice. To what height h will the water jet spurt? So that means we have to find this height up to which the liquid reaches. And we know that at the topmost point of the liquid, the velocity will become 0. So if I know the velocity at the bottommost point, if I know the velocity at the topmost point, so we can use the Bernoulli's principle at these 2 points. So according to the Bernoulli's principle, P1 plus rho g h1 plus half rho v1 square will be equal to P2 plus rho g h2 plus half rho v2 square. This is our Bernoulli's principle. And we know that this is on the atmosphere, so here atmospheric pressure will be here. And this is also on the surface. So here also the pressure will be atmospheric pressure. So at the both the end, the pressure will be only due to the atmospheric pressure. So P1 and P2 both will be equal to the P atmospheric. So if I put the values, we can write P atmospheric plus rho g h1. So if I take this one as a reference level, so we can say that the height at 1 will be 0 plus half rho v1 square. So v1 is the velocity at initially, that is 5 meter per second square. So we can write 5 square. And what will be the pressure at the other end here? So again the pressure is atmospheric pressure. So we will write PATM plus rho g h. What is the height? So we can write height is the total h naught plus h. This is the total height. So we can write h plus h naught plus half rho v2 square. And we know that at the topmost point velocity is 0. So we can write plus 0. So PATM will cancel out. So you will get 25 by 2 into rho will be equal to rho g h. We don't know, but h naught is 25 centimeter. So we should convert it in meter. So 25 by 100. This will be our expression. So density will cancel out. So we can say that h will be equal to 25 by 2g minus 25 by 100. So g is how much? Given that g is equal to 10. So we can write 25 by 20 minus 25 by 100. So when you solve it, you will get 1 meter. So we can say that our option number 4 will be the correct choice. Let's move to the question number 23. In question number 23, it says that if a thermometer X reads boiling point of water at 120 degree X and freezing point minus 80 degree X, what would a temperature of 250 Kelvin be on the X thermometer? And we know that in every thermometer follows the rule of ratio. That means X minus X of the freezing point divided by X of the boiling point minus X of the freezing point will be equal to the, for Kelvin scale we know that K minus the freezing point is 273 for Kelvin scale and boiling point is 373 minus 273. So according to the question, the freezing point for this scale will be equal to 80 degree X and the boiling point is 120 degree X, right? So if I put the value here, we will get X minus freezing point is minus 80 degree X divided by boiling point is 120 minus freezing point minus 80. That will be equal to 250 Kelvin we have to measure. So the temperature of the room is 250 Kelvin minus 273 divided by 373 minus 273. So if I solve it, you will get X plus 80 divided by 200 will be equal to minus 23 divided by 100. So we will get X will be equal to minus 80 minus 46. That will be equal to minus 126. So this is our temperature for X scale. So we can write 126 degree X. So my option number 3 will be the correct choice. Now let's move to the question number 24. In question number 24, it says that two rods of different materials having coefficient of linear expansion alpha 1 alpha 2, Young's modulus y1 and y2 respectively are fixed between two rigid supports separately. Two rods are heated such that they undergo same temperature increment. That means delta T is same. If thermal stress developed in two rods are equal, we know that the thermal stress produced by heating a rod will be equal to the y alpha delta T. But question says that thermal stress in both the rod are same. So we can say that stress in rod 1 will be equal to the stress in rod 2. So according to the formula y1 alpha 1. But since temperature increment is same, so we can write delta T for both. So we can write y2 alpha 2 delta T. So delta T will cancel out. So we can write y1 by y2 will be equal to alpha 2 by alpha 1. So we can say that our second option will be the correct choice because we have to calculate y1 by y2. So let's move to the next question. In question number 25, it says that if 1 kg of ice at 0 degrees centigrade is mixed with 200 gram of steam at 100 degrees centigrade, then which one of the following option is correct? So basically this is a question of calorimetry. We know that in calorimetry, heat lost by the hotter object will be equal to the heat gained by the colder object. Steam here is the hotter object and ice here is the colder object. So heat lost by the steam will be equal to the heat gained by the ice, and let's say the final temperature is something T degree centigrade. So heat lost by the steam will be how much? So since first this steam will converted into water because it is at 100 degrees centigrade and this is the minimum temperature of the steam. So if it cools down, it will get converted into water. How much heat will be liberated when it converts into water? So since there is a phase change, so we will use the formula of the latent heat. That means heat released by the steam will be equal to 200 into latent heat of the vaporization, that is 540. This is the amount of heat released by the steam when it gets converted into water. Now the temperature of the water will fall, and since temperature of the water will fall, so the formula for this will be equal to mass into specific heat into delta T. So mass is 200 gram into specific heat of water is 1 and into delta T. Delta T, let's say our final temperature is T. So the temperature fall will be from 100 to T. So this is our total heat released by the steam, right? And this amount of heat will go into the ice. So first the ice will melt. So since there is a 1 kg ice at 0 degrees centigrade, this is the maximum temperature of the ice. So when you supply the heat, it will first melt. So amount of heat required to melt the ice will be equal to mass into latent heat. And since mass is 1 kg, so we can write it 1000 gram and latent heat of fusion is 80. So this is the amount of heat required to melt the ice. Now its temperature will increase because it is converted into water. Now the temperature of the water will increase, and we have assumed that the final temperature is T. So we can say that the heat gained by the water will be equal to ms delta T, that is 1000 into specific heat of water is 1 into delta T will be equal to T minus 0. Since initial temperature is 0, final temperature is T. So when we will solve it, we will get 108,000 minus 80,000 plus 200 into 100 minus T will be equal to 1000 into T. So 108,000 minus 80,000 will give you 28,000 plus this will give you 20,000 minus 200 and T will be equal to the 1000 T. So we can write 48,000 will be equal to 1200 T. So T will be equal to 48,000 divided by 1200, and that will be equal to 40 degrees centigrade. So we can say that our final temperature is 40 degrees centigrade and whole steam is converted into water. So the final is that water, 40 degrees centigrade, only water will remain. So there is no ice, no steam, only water, and at temperature 40 degrees centigrade. So my option number 4 will be the correct choice because it says that whole ice will melt, whole steam will also be converted into water. This is true, and the equilibrium temperature is 40 degrees centigrade. So this is our correct choice. Let's move to the question number 26.